Hi students, today we will discuss about physical as well as chemical changes. This is our second topic. Today we will discuss it. See, first just what is meant by a change. The definition of change. Change is anything which alter the state or condition. Okay, simply you can remember like this. Simply alter the properties of the substance. Change is nothing but it will alter the properties of a substance. Suppose see here, this is a change. Why? Because the leaves, they are changing their color. That is a change. Here this is the positional change, means this dog is trying to hold this ball. Means it is moving. It is moving. Next, suppose while you observe these two phenomena, observe carefully and let me know what will be the difference between these two. See, the first thing, let us take this one as A. Here some person is tearing the paper. Tearing the paper into small piece of paper. After that, you can, by using the glue, I can reverse the change. Means I can make a paper again as it is. But in the second case, see, burning of paper with flames. Completely, while you burning a paper, what will happen? We will get a ash. Means completely new substance is formed and it will not be reversible sometimes. Means simply these are two different changes. Like this, they are sort out some changes as both physical as well as chemical changes. There are two kinds of changes initially in our nature. That's why they classified them as physical as well as chemical changes. Now see, what is meant by physical change. Here is the definition of this physical change. Simply physical change is nothing but the process where a change occurs only in their physical properties. It is a process where changes occurs where only in the physical property of the particular substance. Let us take like what you call it? Color, then volume, like that, without changing the chemical composition. In physical change, there is no new substance is formed. That is the basic rule. First rule is there is no new substance is formed. But in chemical change, there will be always a scope for new substance. Now let us take some more examples, and these are different kinds of physical changes. Suppose let me take ice which is turned into water. How it will be? Just take that ice cube from the fridge and you will keep it at normal temperature, that is in room. What will happen? It will start melting and it will convert it as water. Again, take this glass of water and keep it in deep fridge again. What I will get? I will get again ice cubes. This means the statement we can convey, physical change is always it is reversible, but not always. Sometimes it is, we can't revert the original position. But no new substance is formed during the physical change. We can conclude only one thing sure, that is new substance will not formed at any cost. That is the major difference between physical as well as chemical change. Let us go for the second example. Water is changing into steam. See here, while boiling the water, take water in a container and boil it. What will happen? We will get some vapors. That is also change. Next, which kind of change it is? It is also physical change. Next, water is turning into ice. While water is turning into ice, just reverse of this one. Reverse of melting is freezing. Simply. Next, steam changes into water droplets. Just collect the water vapors from here. See, exactly reverse of boiling. just collect those stream and compress them and make it as water again. That is also physical change. Okay. Now some more examples for physical changes are melting of wax. Okay, wax I can melt it and again I will get a solid. Okay, next there is a color change. The example is zinc oxide. Zinc oxide initially it is a white color. While heating around 300 degrees centigrade, what I will get? I will get again zinc oxide, but the color is different. Okay, if it is something else, the compound, let us take zinc plus oxygen. It is splitted as zinc as well as oxygen. Then it is something different story. We will treat that one as a chemical change. Here it is a physical change. Next, change in the volume or blowing the balloon. Okay. Next, that is also a physical change. Okay, blow the balloon, it will expand. That is also a physical change. Next, magnetization. Suppose let us take a iron piece of iron and it is by using a permanent magnet you can rub this iron piece. What will happen? The iron piece also acts as a magnet. Okay, temporarily. Why? Because the arrangement of the particles is initially like this. Okay, initially these are like unorganized. Okay, after rubbing continuously it will be arranged in a particular direction. That's why the iron is also acts as a magnet. Okay, this is also a physical change. After few minutes it will again this particle arrangement is again random way. That's why it will loses its magnetic property. It is also a physical change. Okay, next, while observing all these conditions, all these examples, we can conclude these characteristics. Okay, the first one is this process involve change in the physical property only. Okay, what is meant by physical change? Only physical properties will changes during this process. There is no chemical composition change takes place. Okay, chemical composition never takes place. Okay, change in the chemical composition never takes place, means simply there is no scope for new substance in the physical change. Okay, physical change which is occurs in the substance, it is a temporary change. Okay, it is a temporary change, that is we sometimes retain our original substance also sometimes. Next, the mass of the substance is undergoing physical change remains unchanged. Okay, the mass, whatever it may be, the mass, let us take the ice cube and melt it. What will happen? Mass will not be changes during physical change. Okay, but chemical change, mass will be changes sometimes. Okay, now let us come to the second part of the story, that is chemical change. Okay, see here, what is the definition of chemical change? The process which involves the change in the chemical composition or simply of the substance is defined as chemical change. Okay, simply it is a process of change which changes the chemical composition of that particular substance. Okay, means new substance is formed. Simply we can call it as a new substance will be formed during this change. It is said to be a chemical change. Okay, what are the examples? Just let me take these examples: burning of paper, rusting of iron, cooking food, mixing baking soda with vinegar. Okay, these are the examples. Suppose let us see one by one. Burning of wood, what will happen? Just observe this diagram and let me know. Okay, wood is completely burned, means initially it is a wood, after that we are getting ash, means completely changing. Okay, here is rusting of iron. Initially it is a pure iron, but after that what we are getting? We are getting a brown, reddish brown solid layer on that metal. Okay, that is said to be rust. Okay, next, cooking. Daily you are eating something now, that is cooked by some people. Okay, cooking also a permanent change. Okay, we are getting new substances. Let us take example like tea. Suppose, okay, initially you are adding a milk plus sugar plus tea powder, but after we are getting which color? The tea color is something different from milk color. Yes, milk is a white color, whereas it is in dark, what do you call it, tea powder itself, it is a color. Okay, that's why it is a change in color and taste also changes. Okay, now one more example to see, baking of soda. When sodium bicarbonate, which is react with vinegar, that is acetic acid. Okay, acetic acid, it produces carbon dioxide. Okay, simply let us take vinegar plus baking soda in one test tube, and another is lime water. Okay, here we are pumping the carbon dioxide from here to here. What is the product? Water and sodium acetate, means completely you are getting new substances. Here is vinegar is there, here is sodium acetate is there, here is baking soda, here is sodium acetate, here is lime water, here is vinegar. Okay, completely new substance is formed, and sometimes gases may be evolved during that change. Okay, sometimes color may be changes, sometimes some gases are evolved like this. Okay, see, this is a simple chemical change while you are observing eating of any fruit at your home. See, food decomposes due to action of microorganisms like bacteria, fungus are there. No? Okay, those are killed our what do you call it, fruits. This is also a permanent change. It is a chemical change. Okay, new substance is formed that is having some different taste. Okay, we can't eat those spoiled food having different smell and different taste. Okay, now next, this is one more example for chemical change. Take the calcium carbonate and heat it. Okay, heat it. What I will get? I will get calcium oxide along with carbon dioxide. Okay, initially it is a calcium carbonate. It is a solid green color substance, but after that we are getting a gas which is a colorless, and we are getting a solid which is a black color. Okay, completely new substance is formed. Again, see, that is lead. Take lead nitrate and heat it. What will happen? Initially lead nitrate is a solid white color substance. While heating, we are getting solid yellow color substance, that is lead oxide, along with reddish brown color gas, that is nitrogen dioxide, and colorless oxygen gas is also there. Okay, take one substance and we are making how many substances? 3. 1, 2, 3. Like that, chemical changes having different phenomena. Maybe sometimes number of substances also increases and mass also decreases or increases. Okay, one more example is, let us take magnesium, which is burning of magnesium. Take the magnesium ribbon and burn it. Okay, it will react with atmospheric oxygen. What you are getting? We are getting magnesium oxide like this. Okay, this is also a chemical change. And one more example is, take mercuric oxide, that is HCO. Okay, mercuric oxide, it is a solid, and what I will get? I will get 2 atoms of mercury by heating. After heating, what I will get? 2 atoms of mercury along with 1 molecule of oxygen. Oxygen is a liquid, whereas mercury is a oxygen is a gas, whereas mercury is a liquid. Okay, initially it is a solid. Derived from a solid, we are getting 2 substances. One solid is converted into 2 substances. One is liquid, another is gas. This is the specialty of chemical change. Okay, now what are the characteristics of a chemical change? This process may or may not to causes the change in the physical state. Okay, maybe physical state maybe sometimes varies, sometimes remains same. Let us take, suppose initially it is a solid, maybe it is a solid after the completion of change, or sometimes maybe changes. Okay, there is no change in the chemical composition of the substance. Okay, there is a change. There is no change means it is a physical change. There is a change means it is a chemical change. Change in what? Change in chemical composition. The chemical change occur in the substance is permanent. Okay, we can't reverse it back. It is a permanent change. It is not a temporary change. That's why we can't revert it back. Okay, now the mass of substance of substance undergoes chemical change may alter it, either the mass increases or decreases. Okay, the change is caused for mass increase of that particular substance. Mass of the substance may be increases or decreases during the change. Okay, now these are the characteristics of chemical changes. Now let us briefly discuss the characteristics of both physical as well as chemical at a time. See, the first one is characteristic and physical change and chemical change. The first one is changes occurs or not. Okay, change in physical properties only occur, then it is said to be physical change. Change in chemical composition of the substances occur, then it is said to be chemical change. Okay, example, suppose let me take zinc oxide. It color from white to yellow. Initially it is a white color, after that we are getting a yellow color. Okay, and back upon cooling, magnesium, again this is already we discussed. Magnesium ribbon, take the magnesium ribbon and burn it. What will happen? We will get a new substance. Same manner like zinc oxide also. Next, chemical equation. Okay, for physical change we can't write, we are unable to provide any chemical reaction. Okay, but for chemical change I can able to provide a chemical reaction like this. Let us take 2 moles of magnesium and 1 mole of oxygen. While heating, what I will get? I will get magnesium oxide 2 moles like this. I can able to write. Okay, reversibility. Reversible, but there are some exceptions. Okay, irreversible, completely new substance is formed. That is chemical. Okay, next, weight or mass remains constant. In physical change there is no question of either mass increases or decreases, but in chemical change there is a possibility that weight increases or decreases, means it will loses some mass or gain some mass. Next, energy changes. There is no significant absorption or release of energy during physical change, but in chemical change energy is released or energy is observed. If energy is observed, then it is said to be endothermic. If energy is released, then it is said to be exothermic chemical simply change, and it is said to be a chemical reaction. Okay, the energy is observed during the chemical change, then it is said to be endothermic chemical reaction. If the energy is released during the chemical change, then it is said to be exothermic chemical reaction. Okay, this is about the brief introduction of this chapter. Thank you very much.